Moving on to our cosine and tangent. This will probably be the last one where I'm trying to get you to the why it's occurring. Because knowing why helps the how a ton. So a little bit more on the why. And then the next one we'll talk more about the how. And let's look at tangent. Kind of just got it drawn out. It repeats like this forever. It's just a bunch of little, they almost look like cubic lines, huh? Or cubic curves. Stuff like this. And again, we're going to want to try and find the inverse of tangent. Tangent's inverse, where we swap its inputs with its outputs. Where we swap the x's and the y's. And I'm not going to take you through the whole thing I did last time with sine. And I'm just going to show you. We're just going to take it and go, you know what? Nah, we don't want any of this. We don't want any of this either. Because it wouldn't have passed the vertical line test. We would have ended up drawing a bunch of shit that looked like this, just over and over and over and over and over. And we don't want that nonsense. It's not going to pass the vertical line test. So it's basically, we just took and went, you know what, get rid of all the nonsense. Get rid of all the rest of them. And then we look, and we're like, oh, let's keep our x values between negative pi over 2 and pi over 2. Oops, I'm sorry. We're talking about inverses where we swap our inputs with our outputs. Let's keep our y values in between negative pi over 2 and pi over 2. What used to be vertical asymptotes in its inverse now become horizontal asymptotes where it's approaching y equals pi over 2. Why is that so thin? Oh. Y equals pi over 2. That's where it's approaching that. And then it also has one down here where we have y is equal to negative pi over 2. It never actually achieves it. It's an asymptote. Granted, things can cross over a horizontal asymptote, but that's neither here nor there. It doesn't here. There's inverse tangent. All right. Well, let's go up and let's take a quick peek at cosine. Got it drawn up just a little bit, not as in depth, and we're gonna want to go find its inverse. Now this one, we're not going to keep it from negative pi over 2 to pi over 2, just like tangent and sine worked. This isn't gonna cut it. And this one's not going to work the same. We're actually going to get rid of that part. We're going to get rid of this part. And we're going to get rid of this part. We're just going to go from 0 up to pi. We're just going to take the x values from 0 up to pi. 0 to pi. And they're going to become our y values. Again, just like sine, we're going to go from negative 1 to 1. So when we go to draw it, it looks a little something like this. You don't have to necessarily have these things memorized as what they look like. You should know inverse tangent for calculus 1 though. It's their graphs. It's what comes from it. It's what we find from this. Like we look at this graph and we go, all right, well, let's talk about inverse cosine. We have some things like, what about the domain? What's the x values? What are we allowed to plug in? When we look, we're like, well, you can go from negative 1 to 1. That's all good. Those ratios that they used to be. All right, and then our range. We take a look at that. What's this shit? We're like, the range is just the y value. So we go from 0 up to, oh, you know what this is? I forgot to write it in. Pi. The range is from 0 to pi. Wait, when we start talking quadrants, what quadrants is 0 to pi? What quadrants would 0 to pi be? This would be quad 1, quad 2, quad 3, quad 4, right? Isn't that how it works? So we're just looking at quadrant 1 and quadrant 2. Okay. Okay, so what do we find from this? These are our takeaways. For some function inverse sine of x or arc sine of x, our domain is in between negative 1 and 1. Our x values. Our range is from negative pi over 2 to pi over 2. And I'm going to start putting something down underneath and just write quadrant 1 and quadrant 4. It's the only answers that it can ever pop out, because inverse, I'll start repeating this 1,000 times, you're going to hate this. Inverses are angles. When you say sine inverse of x equals, it equals an angle. And that angle that it equals has to be from the first or fourth quadrant. It must be between negative pi over 2 and pi over 2. When we go to inverse tangent, we see that we're allowed to plug in anything we frickin' want to in the domain. Now look, anything you want to. We have horizontal asymptotes. You plug in whatever the frick you want. And our range is in between negative pi over 2 and pi over 2. But it never achieves it. Why? We use parentheses here instead of using the brackets on sine inverse. But this is still only defined when those angles are between negative pi over 2 and pi over 2. That's quadrant 1 and quadrant 4. So that has the same quadrants as sine inverse. Cosine inverse does not play nicely. You're going to see when we start showing you the how, why this one, it doesn't play nice. Our domain is the same thing as sine inverse, because both sine and cosine are trapped between negative 1 and 1 when we graph them. But its range is between 0 and pi. This has a different angles that it could be. It's from quadrant 1 and quadrant 2. It differs from sine inverse and tangent inverse. Don't stress about secant inverse, cosecant inverse, and cotangent inverse. There's not much reason to ever even speak about them. Going the other direction, there's just reasons why, and I'll show you later why. It's nonsense. Don't waste your brain space with it. Let's know sine inverse, cosine inverse, and tangent inverse. I'm going to put one thing in one time to repeat. Tangent inverse does not equal sine inverse over cosine inverse. Okay? That is not true. That is not true. The inverses don't work that way. Inverses are angles. Everything works differently this way. For now, all we're doing is swapping our inputs with our outputs, our ratios with our angles. In the next one, we'll start talking about how to do this.